Welcome to our deep dive into the world of statistics. It's more exciting than it sounds, trust me. Today we're exploring the different types of correlation coefficients. These little guys are like the detectives of the data world, helping us uncover hidden relationships between variables. Get ready to see how seemingly random events might actually be connected in surprising ways. First up, we have the Pearson correlation coefficient, the most common of the bunch. Imagine you're plotting data points on a graph. The Pearson coefficient tells us how closely those points form a straight line. A perfect positive correlation with a coefficient of +1 means as one variable goes up, the other does too, in a perfectly linear fashion. Think about the relationship between hours worked and money earned. On the other hand, a perfect negative correlation with a coefficient of -1 means as one variable rises, the other falls in a perfectly linear way. Picture the relationship between the distance you are from a light source and the brightness of that light. And of course, a coefficient of 0 means there's no linear relationship at all. Now, let's say our data points aren't forming a perfect line, but there's still a clear trend. That's where Spearman's rank correlation coefficient comes in. It doesn't care about a perfect line, it cares about order. Imagine we are ranking a group of marathon runners. Spearman's coefficient tells us how closely the order of their finishing times matches up with, say, the order of the number of miles they ran in training. A coefficient near +1 means they strongly agree, near -1 means they disagree, and 0 means there's no relationship. Similar to Spearman's rank correlation, Kendall's tau is also interested in order and ranking, but it takes a slightly different approach. Imagine we're looking at how two judges rank a group of singers in a competition. Kendall's tau measures the degree of agreement between the judges' rankings. A high tau close to +1 means the judges are pretty much in sync, while a low tau closer to -1 suggests major disagreements. And of course, a tau around 0. Well, that's like saying the judges are practically picking names out of a hat. Sometimes we need to see if there's a connection between a continuous variable, like height, and a dichotomous variable, which has only two categories, like whether someone plays basketball or not. That's where the point biserial correlation coefficient swoops in. It helps us see if knowing someone's height gives us any clue about whether they're likely to be on the basketball court. A high coefficient, approaching +1 or -1, suggests a strong relationship, while a coefficient near 0 means height doesn't tell us much at all about their basketball skills. Finally, we arrive at the phi coefficient, our specialist in binary variables. Think of it as the ultimate relationship guru for yes/no questions. Let's say we want to know if there's a connection between owning a pet and being happy. The phi coefficient can tell us if these two things tend to go hand in hand. A large phi close to +1 or -1 indicates a strong link, while a phi near 0 suggests owning a pet doesn't really affect happiness levels. Thanks for joining us on this statistical journey. Remember, just because two variables are correlated doesn't mean one causes the other. Correlation simply reveals interesting connections, like clues in a cosmic detective story, but who knows, maybe those clues will lead us to even more profound discoveries about the universe. Don't forget to like, share, and subscribe for more insightful content.